Hello everyone, my name is Anthony Mnyarazi and I'm here to walk you through my journey for the course ENPM 701 Autonomous Robotics at University of Maryland. The course was both challenging and rewarding because it gave us a chance to apply engineering principles in real-world robotic applications. The course wanted us to use all the aspects that we have learned from day one, that is, modeling, control, perception, and planning. This was preparing us for a grand challenge which was to be carried out on the final day, whereby we would have our robot start from the origin, goes into the scattered environment where it would pick blocks of different colors and put them in the target area. This tested our ability to deliver an autonomous working system under pressure. To build a robot capable of completing the grand challenge, I went through a series of structured assignments, each one adding a key component to the system. Let me walk you through the evolution. So it all started with data cleaning using moving averages. This was essential for smoothing noisy sensor readings, something I would rely on heavily later on for things like IMU, data, and encoder feedback. The second week was exciting because that's when we received our keys. It was our first time to use, for me, it was my first time to use the Raspberry Pi, so it was really exciting. It was all about setting up the Raspberry Pi. I made sure that everything worked, starting from the camera, the GPIO serial interface, and practicing capturing images and videos. This step laid a foundation for visual tracking later within the stages. We moved on to using HSV color masking to detect specific colors in the environment. The professor gave us red, green, and yellow blocks, and I refined the threshold and tracking logic to determine these colors under different lighting conditions. We went on further to detect the edges of the corners of an arrow. This was on the focus to to track orientation. So this would show whether the arrow was upright, pointing downwards, either left or right. Then Homework 5 brought in the sonar sensor. I integrated it and annotated the live feed with real-time distance measurement. This gave me an initial sense of obstacle proximity, which was also useful during navigation tuning. Homework number 6 was important for me because I did not have much understanding of the control of motors. So developing motion control using wheel encoders was part of it. I used tick counts to estimate distance traveled, allowing the robot to move predictable distances even without external feedback. I then later on added the servo control for the gripper. I could now open and close the gripper in response to visual cues, which became central to the robot's ability to pick and place blocks. Homework 8 was all about improvising localization by incorporating IMU. I fused its angle readings with encoder data to enhance the robot's understanding of its orientation. This was critical for rotation accuracy. And finally, Homework 9 brought all the stuff together. I developed a logic to track the block's position relative to the camera center, enabling the block to align itself precisely with the block during pickup operations. Each of these modules fed into a cohesive system, hardware, sensors, and softwares, working in real-time, drive decision-making. Between segments, I will show clips of the robot performing specific tasks as you are seeing from the background. Now come to the highlights of the Grain Challenge. The Grain Challenge was really exciting. Everybody was prepared for the day. My robot was also part of the team, and I actually was part of the competition. My block couldn't actually get to the stage of picking blocks because 2 times I hit the boundaries. So once you hit the boundaries, you get off the competition. So to wrap up, this project taught me so much about system integration, control theory, and perseverance. I now understand how theory can translate into physical systems and the importance of debugging and iterations in robotics. Special thanks goes to my instructor, Dr. Stephen Michaud, for his support and guidance throughout the course. Thank you all for your time. I hope the presentation was clear.